All right, let's try this again. Okay, so B is undefined. Undefined, giving us no possible triangle, or I'd say A, B, C does not exist. But before I talk about that, I'm going to say why this is undefined, okay? That's because when I have this expression here, oh, I don't want pi, because 25 sine 85 degrees over 15 is approximately 1.66, and sine inverse does not have values above that. Okay, so I'm going to lasso this, move it over a little bit so I don't use up all my space, okay? Sorry, I know it's a little wacky when I do that. Okay, let's try this again. Because equals defined and sine inverse does not have values outside. All done? Okay. Outside, you can unlock my phone and then I'll do it. Outside the interval -1 to 1, and that's definitely outside that interval. Okay, the next example here, example number 5, is actually going to take up quite a bit of space. I'm going to get a new sheet here. We'll flip this one over, okay, because this one's going to have 2 triangles, and when you have 2 triangles, you need like double the amount of space, okay? So I might write only the essential stuff in the margin so that I don't cloud the space with tons of writing. Okay, so let's go to the textbook here. Okay, and for example 5, see how much space it's taking up? Lots and lots of space. Okay, so it wants us to find 2 triangles. On the test, it's not going to tell you that there are 2 triangles, so I'm going to write it the way it would be on a test, okay? So here I go. It's 12, 31, and 20.5. Okay. Okay, and over here, I said solve for all possible missing side lengths and angles for triangle ABC, where, okay, I'm going to copy that. Uh-oh, don't mean to do that. Uh-oh. Sounds like Hector's phone's ringing. Okay, I wonder if I can copy that. Let me see. Yeah, maybe that won't work. Okay, I'm just going to have to write it down again. That's not doing what I wanted it to do. Control copy. Yes. Okay. Yep. Okay, I gotta move that way up because I don't want it down there. Right. Okay, did that at the very bottom of that. Okay, I could have so written this so much faster. If I had just done that, it would have been so much better. All right, well, I'm just going to delete that because it's not doing what I want to do. So sorry about that. Uh-oh. Control Z. Darn it, I'll delete that later. Sorry about that, guys. Okay, so this is example 5. It's still on page 407, and it's going to say solve for all possible side lengths and angles where or for triangle ABC. Oh, my nephew's calling me. Hang on a second. Hey, Riley. Hey, Riley. Are you there? Riley? Hello, nephew. Hi. Hey, not a whole lot. What's going on? No, not right now. He's napping. Yeah. I don't think he will be for long, though. I think he's been napping for a while. Were you wanting to come by and help him? Uh-huh. Let me go see. Give me a second. Say it again. Yay! Okay, see you soon. Okay, bye. All right, so sorry about that. All right, so solve for all possible side lengths and angles for triangle ABC. Hey, boys, you're a bit loud. Boys, I'm making a video for work. Can you guys quiet it down a little bit? Okay, so textbook. Okay, it was 12, 31, and 20.5. Oh man, I already forgot what B is. Dang it. Oh, 31 and 20.5. Okay. Oh, and I don't think that was angle B. I think it was angle A. Okay, double check that one last time. Okay, that looks really good. Okay, hang on for just a minute. I need to turn off the TV. Oh, you're watching TV now? All right, sorry for that, students. Okay, it's just easier for me to do that than to splice the video, so maybe I can edit that out in a little bit. Okay, so I was right. Okay, so again, the first step is to sketch it. Okay, so A, B, C. Angle A is 20.5 degrees. B is 31. And side A is 12. Okay, we're going to set up our equation to solve for b. Okay, so that was, okay, so that's my step 1, that's my step 2. Okay, so sine b over 31 is equal to sine of 20.5 over 12. Okay, I am going to multiply 31 on both sides. And then we're going to take the sine inverse of both sides. Okay, and that helps us to eliminate this here and here. Okay, I'm not going to get out my Silver Desmos this time because it's going to make me cancel my recording. So I am using my handheld calculator this time around. Yes, Carter?
Can I take the back yet?
Not yet, honey. You need to finish making my video, okay? So I'm doing sine inverse of 31, sine 20.5, and then I'm putting the 12 in the denominator. And I get 64.8 for angle B. Uh-oh, did not mean to keep that in there. Okay. Okay, I'm rounding to the 10th place because the decimal value that I was given is 20.5. Carter, can you not do that in this room, babe? I'm making a video. It's going to make me take a lot longer if you're making noise while I'm trying to get it done. 64.8. Your cousin Riley's coming over.
Did I?
Yeah. You gotta not be so loud, okay, hon?
I know.
Okay, so here's the thing. I can solve for this triangle, but I might have an ambiguous case. So let me explain what this ambiguous case is, okay? You have to check for the ambiguous case anytime you use sine inverse to solve for an angle in the law of sines, okay? So, let me see. Check for a second possible triangle. I guess I don't need a cursive F there. And we're doing that because we use sine inverse. So you really want to avoid using the inverse whenever possible. Okay. So the reason this happens is because sine inverse, again, only has values from -1 to 1. So if you remember from Unit 2, Carter, I need you to stop, babe. When I did sine inverse of, say, something like 1/2, we knew that we looked in quadrant 1, okay? Because that would go all the way up there to my 90 or my pi over 2, okay? And then if I had a negative, then I would look in quadrant number 4, and I would use a negative angle. Okay, so this is -90, and so here if I was doing -1/2, then we would say, oh yeah, that equals -30 degrees. Carter, I'm going to take them away. I'm making a video for work. I need you to go into another room while I do this, okay?
Yeah.
You're too loud. Okay, so sometimes it's going to give me a negative angle when it should probably be an obtuse angle, but my calculator is really going to give me that positive angle, and I need to account for a possible obtuse angle, okay? So we are looking at angles between 0 and 180, but sine inverse doesn't go on the other side of the 180. So we need to check if that triangle is actually over here, okay? So let me refrain or explain that again. So this angle is always going to be acute. Okay, but sometimes we need an obtuse angle because there are obtuse angles in triangles. So sine inverse doesn't just give you an angle, it gives you a reference angle. And so if I had an angle like, let's say, we have that 46 point whatever, what was it, 64.8, that could mean it's this angle here, or it could mean that it's this angle here. Oh, I keep doing that a little bit wrong. In either case, there's potential for another triangle. Okay, so I'm going to put the 64 here. Okay, I could have this one here. Notice that it still makes a triangle. They look different, but it does make that second triangle. Okay. Okay, so we're going to check for that. So to do that, if we were trying to find this angle here, we would just go 180 minus that number, 68.4. Okay, so I'm going to call this one B1. We're checking for a possible second triangle. Okay, but to do that, really what I'm looking for is a possible second angle for B. And this one would be obtuse. Okay, so to do that, I'm going to subtract the B that we found there from 180. I'm going to call it B1. Okay, so I'm going to go B2 equals 180 minus 64.8. Okay, and 180 minus that value there, and I get 115.2. I need to use an approximate symbol. Okay. Okay, so then the first thing I'm going to do is, does that angle fit into a triangle? Okay, so does it make sense? It makes sense because you can have a big obtuse angle because it's smaller than 180. It's not negative. Okay, so it looks like it could work. But in order to figure that out, we have to see what angle C is. Okay, that's the only way to know for sure. So we're going to try to solve for two triangles here. We're going to solve one for this one, B1, and we're going to solve a second one for this one and see if it works. Okay, so let me do that. Shrink it down a little bit because I wrote super big. Ooh, you want to go open the door? Is it Riley?
Yes.
All right, let him in. Hey, Riley.
Hello.
You use a phone now. All right, Carter, do you know where Hector went? Where your dad went?
Is he up?
Yes, he is up.
Did you wake him up?
I kind of whispered to him, and he heard me, but he didn't get up until like literally 30 seconds ago. I'm videoing a lesson for school right now, so I'm going to 6th grade camp tomorrow.
You're videoing a lesson?
Mm-hmm.
You video yourself?
Yeah, so like it's recording me right now. I'm 19.47 seconds in.
Oh, it's only recording what you write?
It's recording what I write in my voice.
So, and my voice?
Yeah.
Uh-oh.
So you're on video right now. Ooh, I'll tell you all about it when I'm done. Okay, so now I'm going to check for two possible triangles. Okay.
Huh? How do you get it? How do you get it?
Okay, I'm going to shrink this down also.
How have you been? Hmm? Good?
Boop.
What are you trying to do? Hey, what's up, Emily?
Okay, so in fact, I don't even know if I really need that. So let's take that again.
Okay, so these two said they're good. How are you doing?
Mm-hmm.
Good. Hello. How are you? Hello.
I know, you didn't see Riley last week when he was here, Carter. Okay, so I'm going to move these actually also.
Use your words.
Well, my promise is almost going to be done already.
Good.
I'm not going to be good, but you're going to with me.
Good.
Can you want me to go check it out?
No, I'm doing a video right now for work. I'm going to camp tomorrow, so I need to get this done. Okay, so I'm going to put my two pictures under the two situations here, okay?
You know if you're doing good? You haven't been doing good?
Sorry, I know that means you have to move stuff possibly, but you don't. I'm just doing this because I'm going to actually print my notes later and leave them for you guys to look at. Okay, so that means that this angle right there is, let me highlight it here. This angle right here is our angle B, which is 115.2. But in this one, our option has this angle right here. Okay, so we're going to try to now solve for C. In either case, we're going to use the interior angle sum.
Oh, you like drawing with colors? Or just with a pencil?
Interior angle sum theorem to solve for C1 and C2. Okay, so 180 minus 64.8 minus 20.5. No, not right now. No, honey, begging me please isn't going to work, okay? And then I'll do the same thing for C2. That'll be 180 minus 115 degrees. Oh, 15.2. No, he's putting on shoes, Carter. You can go watch, but you got to stay out of the way. Okay, so for this one, I get C1 with the possibility of minus. It's a lot of work, Carter. Okay, so for this situation, I get 94.7 degrees, and that's good. It's an obtuse. Remember, we can't have more than one obtuse angle. Okay, but for the second option, I would have my 180 minus the 115.2 minus 20.5, and I get 44.3, which also seems reasonable. When it would not be reasonable is if this angle were negative. Okay, so let's see here. Here's my angle C, and that means that we have a second triangle. They're both positive angles. Okay, so then we're going to solve for side C for both. Okay. He's in the front yard or backyard. He's hanging up Christmas lights with Riley.
Oh, Christmas lights?
Mm-hmm.
Yay!
Yep.
Can we get the Christmas tree up this week or next week?
No, I'm making a video right now, honey. Next week, okay? Let me finish my video, please.
Sorry.
That's okay. Okay, so solve for sides C1 and C2 since two triangles exist. Okay, so to solve for C, little c1, I go c1 over sine of, I'm going to use that 94.7. It's approximately equal to that given side angle pair, which we said was sine 20.5 and 12. Okay. Okay, and then I'll multiply both sides by sine of 94.7. Okay, and so I'm going to go 12 times sine 94.7 divided by sine of 20.5, and I get a side length of 34.1. Okay, and then I'm going to solve for side length C2. I'm going to put that over its respective angle. That's 44.3. I'm going to use the same angle side pair because the side 12 and the 20.5 is the same for both triangles. I'm going to multiply by sine 44.3 on both sides. Okay, so let's enter that one in now. There. 12 sine 44.3 divided by sine 20.5, and I get 23.9. Okay, and so let's highlight that, and then I'm going to write my answers real nice there. Okay, this sine 94.7 came from up there, and then this 44.3 came from the one above there. Okay, so I write my final solution as such. Let's look at this. Hang on. Triangle ABC has two possibilities. Okay, B equals or is approximately 64.8. Okay, so for the first triangle, did I say 64.8? Angle C is approximately 94.7 degrees, and side C is about 34.1. Okay, and you could add the little ones there if you want. Okay, and for the second triangle, We have B is approximately 115.2. Angle C was 44.3. And then side C was 23.9. And you can add the little 2's if you want for each one. That's really just to help you keep everything in order. All right, and there's that other note that I had there. Okay, so this should be all you need to do tonight's homework. Let me just double check our textbook to see if there's any more examples in this objective that we need. Okay, we're not doing area. Not doing area. We are not doing the applications. Okay, so you can work on homework. That's awesome.